Okay. All right, so we're gonna get started today. So yeah, I didn't get a lot of sleep, mostly because I was working on final details for the project. So we're gonna talk about the project today, and then we'll talk about what we talked about last class. So we're gonna finish that up, and then we have one new exercise as well that should help with the project, and that's all we're gonna go over today. And then starting on Wednesday, we're gonna at least hopefully we're going to start chapter 4, which is going to be scripting. Okay, and then also I know the quiz last time that was again, not really ideal. So I think we only had really one quiz that kind of went well. That was like the first quiz. So I'm still trying to figure out, I guess, even though we're pretty late in the semester, the best way to do a quiz, online here with MATLAB. So it's easier for me to just have a script where I can run your code now, and then I can debug it more easily. But then yeah, that didn't work out very well because you had to submit it on your own. So I'm trying to look into if there's like an online version for grading on MATLAB, but I don't think the school has that. So anyways, I'm gonna try to look into better ways for doing the quizzes. And if you see that you have a 0 right now in the quiz, you don't really have a 0. I haven't had time to grade anything yet. So I'm gonna get to that. Hopefully I can start grading tomorrow. Today's gonna be too busy too, but tomorrow I'm gonna start grading them. Yeah, one was at 252. Yeah, I don't know how I was working on all your stuff. Gotta get it ready. So the project details, most of it is on Canvas right now. I still need to upload the data for all of you guys, but we'll get to that once we start talking about it. All right, so are there any questions in general for the class before we talk about the project? Yeah, that might be a good idea. I want you guys to basically, if we're doing it the same way as last time for the quiz, to obviously submit it on time. And I know it's that's just another thing that if you have to submit it yourself, you need to think about submitting it on time rather than just on Canvas. The time goes up and you take whatever you have then. So anyways, I'm gonna try to work on that. I'm thinking maybe I can just have you can write your script in MATLAB, you can work on it in there, and then you can just copy and paste it in a text box on Canvas, and then I can take your MATLAB code and copy and paste it into MATLAB myself and grade it that way. That's a little bit of work on my end, but that'll work better. But I'll figure it out, and then hopefully I can get it, working more smoothly for next time. Okay, so yeah, for how some of you people noticed when I uploaded some of this stuff onto Canvas, didn't mean to go out of that. I uploaded some things on Canvas last night, or I guess this morning. So if you go to the home page, so I'm going to upload details. I'll basically have a little hyperlink here where you can click on project 1, and that'll give you, once you go to that page, you'll see the project deliverables, the due date, and all of the data that we're going to have. But for now, if you go to week 9 on our homepage here, you can see our deliverables up top right here. So project 1, COVID-19 deliverable. So if you click on that, you can open it or download it. And here we go. Okay, so this is project 1. So you can kind of read through this on your own. But what we're going to do is I'm going to give you some data sets for COVID-19. This will be data sets for kind of global, so different countries, states for the United States, and then at a county level as well. So I'm going to provide you the data sets, and I only want you to use those data sets. And so I will provide them. I'm going to upload them basically right after class, and I'm going to try to upload or update them each day. So your report is going to be due on November 9th by 11:59 p.m. So if you remember in the beginning of the semester, I mentioned that our projects, they're going to be in a kind of report format. It's not going to be too much writing, so don't worry that much. I'll talk about that kind of outline as well. So your report is going to be due November 9th by 11:59 p.m. So that's 3 weeks to work on it. And for your figures, I want you to include figures, or I guess COVID data up to November 6th. So yeah, so your report should have all the figures in there. It should be basically up to date, right? Where it's on November 6th. So this won't be an issue for your MATLAB code. You can write out your code and basically you can update it each day or update the data each day. So basically you won't have to change anything in your MATLAB code, but your figures are going to change with that new data. Okay, so project deliverables. So in this section here, I kind of go over what kind of graphs I expect for you to have. So I broke it down by globally, states, and then counties in California. So for globally, what we have here is top 10 cumulative COVID-19 cases by country. And I'll talk about this little star here in a bit. So I want to see graphs for this on a bar chart, on a rolling line plot, on a rectilinear scale, and then a log scale as well. So what I mean by a rolling line plot is basically a line plot that shows day by day how the cases are increasing or decreasing. And then we have top 10 COVID-19 deaths by country. So that'll be very similar to what we have here with the cases, but you're just going to change basically what data you're extracting. So instead of cases, you're going to do it by deaths. Pretty sad. And then we have states here. So you're going to do total deaths per 100,000 people by state and in descending order. So I specified the order here. Typically, this is how you would want to have all your other graphs. But basically, it's going to show the state that has the highest amount of total deaths per 100,000 people, and then it's going to go down and down and down. Okay, and then we have California counties. So this part here, this is probably going to be the most challenging part of the report, but I think it's also the most interesting and it's the most, relevant to us. Unless you're actually, living in a separate state right now and you're still just going online for school. But the first thing we have here is cases. So you're going to do new COVID-19 cases per day on a 7-day average for the top 5 most populous counties in California. So that's quite a lot, right? To kind of pack into one image. And then the next one, so we basically have all of what we have here in this plot, but we're adding on another kind of aspect or parameter. So that's going to be new COVID-19 cases per day taken on a 7-day average per 100,000 people for the top 5 most populous counties in California. All right, so this 7-day average thing, you've probably actually seen some graphs like that, whether you realized it or not for COVID-19. But this will be part of the lecture today, kind of talking about how we can implement that in MATLAB. Okay, and the next section is deaths. So we have cumulative deaths for the top 5 most populous counties in California, and you're gonna do that on a bar chart. And then we have cumulative deaths per 100,000 people for the top 5 populous counties in California. So this part here, it's very similar to what we have here for the cases, but it's just going to be a bar chart. I actually need to go back, so I'll update this later today. I should specify the kind of graphs that I want to see in this section here. So they're going to be basically rolling line graphs. So I'll update that right after class, basically, and then these ones right here, 3 and 4. Okay. I'm actually going to make a note so I don't forget. Okay. So these last two, 3 and 4, these are actually going to be the kind of same style of graph as graphs 1 and 2 for cases. Um, so 3 and 4 for deaths here, and then 1 and 2 for cases, they're going to be those rolling kind of line graphs that I talked about. And then 1 and 2 for deaths, those are going to be bar charts. So at some point, I'm going to actually upload the figures that you should see, basically. So it'll be like a good reference or a good kind of point of comparison to see if your graphs are correct. So obviously, they're going to be correct if you extract the data right and do your calculations correct. So, you're going to have to do basically, I think, one calculation for this report. And that's going to be when you have a graph for something like this, where it's COVID cases per day on a 7-day average per 100,000 people. So that part right there, per 100,000 people, you're basically going to have to do some kind of interpolation. So that'll be the only calculation though. But again, I'm going to upload those graphs at some point. Basically, I want you to get started on your own though, and kind of see where you can get. And then I'll upload the graphs, and that'll be a point of comparison again. Okay. So any questions so far in the report? Okay. All right. So we're going to have some write-ups for this report. So every time that you see a little star, that's going to indicate a figure that you should have a write-up on. So if you look here for our deliverables, you can see we have a star right here, we have a star here, and a star here. So every time you have a star, that's when I want you to basically copy and paste your code into your report. And then you're going to break down the code kind of section by section. And you're going to discuss what basically each line of code or section is doing. And I have an example of that at the end of this handout here. So we're gonna get to that pretty soon. Okay, so you're gonna have basically, again, there's three figures that you're gonna have commentary on. And I also list them out right here. So you should have a write-up for these kind of three figures here. So we have cumulative cases by country. So that was up top here. So you're gonna have you're gonna copy and paste all the code that you used to get these plots here, this bar chart, this rolling line plot on a rectilinear scale, and then this rolling line plot on a log scale. And again, I have an example at the end, and that'll kind of clear some stuff up. And then we have it for new cases per day on a 7-day average per 100,000 people for the top 5 most populous counties in California. So I chose this one because it covers a lot of the kind of similar code that you would use for, like this first bullet point here. And then the last one we have is cumulative deaths per 100,000 people for the top 5 most populous counties in California. So these last two, they're somewhat similar, but on this one, on the second point, we have new cases per day on a 7-day average, while the last one we have cumulative deaths per 100,000 people. Okay, and take note right here, if some sections of your write-ups use the same code, you don't need to write out the basically your explanation again. You can just reference when you first discussed that kind of code syntax. So, if you had two sections where you use the exact same kind of syntax for making a plot, you just have to explain that syntax, in your first plot. And then once you get to your second plot, you could say, this code reference the explanation for, the first figure, something like that. And I kind of have, again, an example at the bottom that we'll discuss. Okay, so in this section here, we have the structure for your report. So you're first going to start off with an introduction. So basically tell the reader what you're going to show. So obviously we're showing COVID-19 kind of data visualization. And then what are the general steps that need to be taken to do this? So kind of briefly outline what you're actually going to be doing inside of MATLAB and what figures you're going to show. And then talk about why these skills in MATLAB, why they might be important in a setting outside of the classroom. So basically just kind of think about the coding that we're doing and this data visualization, why it might be important in a setting outside of this classroom, or I guess your home in this case. All right, and then our section for results and deliverables, we talked about that up here. That's where you're going to provide all of your figures, and then for 3 figures, you're going to have a write-up on that. Okay, and then we have the appendix. So in your appendix, you're going to have a list of figures. So that's going to be the figure number, a caption that you had for the figure, and then the page number for that figure. All right, and then the last part, you're just going to copy and paste all of the code that you have for the project. Okay, so let's look at our example here. I think that'll hopefully clear some stuff up if you have any questions. So here I just kind of made an example for the kind of exercise that we were working on last class. So here, if I'm gonna, start talking about our script, I'm gonna start it out with a little section here. So I have I guess a subsection called importing data. That's the first thing that we do in our script. So you're gonna provide, I guess commentary or an explanation of what you're going to be doing. So first, before we begin the meat of our script, we have to use some bookkeeping. So that'll be clearing our memory and then importing data. So we begin by creating a title for our script and stating our name, and then we clear the memory and clear the text from our command window. And then step 2, we have to import the relevant data for the report. Okay, and then you can see right here, this is when I kind of break down each line of code. So line number 2, we're importing our spreadsheet that has our data as a table. And then why are we doing this? We're doing this to store data of different types. So whether we have strings, numeric arrays, or datetime. All right, and then line 3, we're going to sort our table by some parameter. In this case, if you remember from last class, we sorted our table by a weighted on base average from highest to lowest. Okay, so you're just going to basically, provide your code and then explain what that code is doing. Now, you don't need to follow, this exact kind of style that I have here. You can do it in whatever kind of style you think works best, but it should be in a logical manner and it should be easy to read. Okay, and then see, I have a new section here. So I have a kind of another header here, and this is going to correspond to one of the plots or figures that I'm making. So remember from last class, we made this plot down here. That was a stem graph. So I have that title right here. So that's weighted on base average for the top 25 players in MLB. Okay, so the first part of this kind of section of code, we just had to write out a line of code to make our plot, right? And then I break down basically each part of this line of code. Okay, and then I go to the kind of next section in our code for this figure, which was the formatting for the x-axis. All right, so I break it down line by line. Okay, now you'll see here when we had to format the y-axis, lines 1 and 2, that was changing the ticks for the specific axis and then the kind of the range that we have for that axis. So here, because y ticks and y lim, that kind of syntax is very similar to what we had up here for x ticks and x lim. Because they're similar, I don't need to go through this kind of explanation again. I can just say reference when we talked about our x-axis formatting up here. Okay, so for you, this might be, a reference to a whole different figure in your report, and you can kind of do it that way as well. Just make sure that you reference that specific figure. All right, and then the rest of it, I discuss each of the other lines that we have here in this code. And then once you're done explaining all of the code for that specific figure, you're actually going to present the figure. All right, so any questions so far? Okay. So what I'll actually do is I'm going to show you one of the figures that you're going to work on. Actually, I guess I'll show you two. All right, so here's one of the figures that you're going to have for your report. So again, I'm going to upload all of the figures probably in, I don't know, maybe by this weekend, something like that. Because again, I want you to start working on this on your own and kind of start building up these graphs. But then this weekend, I'll upload all of them and you can kind of make sure that your graphs look the same as mine. All right, but I just want to provide some, I guess, context or motivation here, right? So for this graph here, we first have new COVID-19 cases on a 7-day average for the top 5 most populous counties in California. So that was, I don't know, I think that was like section 2 or something for our deliverables. We can go back and we can look at that. But okay, so this is what we have here. We have Los Angeles, San Diego, Orange, Riverside, and San Bernardino. Okay, so this is what it looks like, right? So you'll see here I'm using a 7-day average, and that kind of is going to smooth out our plot. We're going to talk about that today for one of our exercises that'll kind of make it clear for why it's good sometimes to do like a 7-day average or a 5-day average or a month average, whatever it might be. Okay, so this is one of the plots, and then if I go to the next one here, this is the same data, right? But now I'm taking it per 100,000 people. So this is a better way often to kind of look at COVID-19 data. So in the previous plot, Los Angeles was so much higher than the rest because they have a larger population. But once we break this down to per 100,000 people for that specific population size, then we can kind of better compare these different counties. So you can see Los Angeles in blue here, and then you can see San Bernardino in green. So yeah, really, they had the highest amount of new COVID-19 cases. My title should actually be a little different. They should say new COVID-19 cases per day by a 7-day average per 100,000 people. And so I'm not requiring you to do this for the report. But if you want, you can kind of look at these days here. So we see in between August and September, we had another spike, right? For most of the counties, but Los Angeles and San Diego, they did pretty well then. But Orange, Riverside, and San Bernardino, they kind of had this spike again in between August and in general now we're going back up again. Okay, so that's all we're going to talk about, at least for now, for the project. But if you have any questions, put it in the chat right now. Okay. All right, so before we get started on kind of finishing up what we did last time, I actually want to show you what some of this data is going to look like for the project. Okay, let's see. I'm going to stop sharing my screen just because I don't want to accidentally show my code. Okay. Okay, so this is going to be one of the kind of data sheets that you're given. So here, these are all of the California counties, and we have the total count confirmed. So that's going to be the cases that we have. Total count deaths, and then we have new count confirmed, and then new count deaths. Okay, so where it says new count confirmed and new count deaths, that's by day, right? All of these rows are by day. So if we look at our column for the date, it's actually even more than by day. It's there's multiple readings per day. Actually, no, there's not. That's a different graph. So here we have it starts on March 18th, and then it does go by day. So I was thinking about a different graph or a different spreadsheet. Okay, so this way you have cases here, total amount of cases, total amount of deaths, and then the new amount of cases and the new amount of deaths. So it starts out with Santa Clara, and then we can keep going down. I guess it doesn't show our, at least I don't see right now. It doesn't show how many rows we have here, but it's a ton of data. So I'm going and going and going. So it's a pretty big spreadsheet. But again, we have all of the counties for California. I'm gonna go back up here. So there's gonna be I think two kind of, in quotes, counties that you're gonna have to take out for this project. So this says out of country. We don't really care about looking. We don't care about looking at that because that's not relevant to us, and it shows all zeros anyways. So that's one, and then there's another that's called unassigned. So I don't see it right now, but oh yeah, there it is. Okay, unassigned. So we're gonna take that out as well because that's not really relevant to us. We just want to look at the, actual counties. All right, so that's one spreadsheet. So they basically all, are similar to this, where they show the total amount of cases, total amount of deaths, and then and maybe they might show the new cases and the new deaths. I'll close out of that. Let's actually look at the global data as well. I can't preview it here. Clicking the wrong one. All right, there we go. So this is going to be the global data that we have. So it shows by date. So that goes by day. Then we have a country code, and then the actual country name, the region that we have, and we have new cases, cumulative cases, new deaths, and then cumulative deaths. All right, and this is, again, it's going to be a gigantic spreadsheet. So you can't really go through it manually, and you shouldn't. You're going to have to write some code, specifically array addressing. All right, so you have all that data there. Yeah, this is all real data. what was the first one called again? What, the first spreadsheet or what? There's two that we had to delete. Yeah, so the first one, so Karen is talking about what we had to delete from our spreadsheet here, which is county data for California. So there's kind of like two, I don't know, fake counties. So one of them is called out of country, and the other is called unassigned. So to remove those, basically what you do, you would use some kind of matching kind of function. So you'd do something like find is member, like we talked about last class. You'd specify this table here, and then you'd put in the string called out of country. And then you'd also do that for the string of unassigned. All right, I'm just scrolling through to find it again. See, but even scrolling through right now, it's taking a while. So this is why we're going to write code, right? All right, so out of country and then unassigned. All right, I'm not going to find it. It's in there though. Okay, so I'm going to ask one last time any questions on the project. I would have thought that there would have been more, but maybe not.
One question. And you said, Ed, that for the report we're going to be printing multiple graphs. Fs. So how do we import those graphs to another document and from one instance of the code?
So just saving a graph and putting it in your document, right? That's your question?
Yeah.
Okay. Um, I can't remember if I talked about it in this class or a different class. I think I did talk about saving figures once in this class. So to do that, what you have to do, you can run your code. Your graph is going to pop up here. And then you're going to go to File, Export Setup. And then you're going to click on Rendering here under this kind of drop down. And then change the resolution here to at least 300 dpi. I'm kind of going fast because I think I do have them in some slides, or you can look back on this. Then you're going to click on Export. And then you're going to save that to whatever folder that you want to save it in. And you're going to change the file type to either a .png, or even better, save it as an SVG right here. So that's a scalable vector graphic. And if you save it as a vector, it's going to be very, very high quality. So then, when you're in Microsoft Word, you're just going to do File, Open, and then just import that figure in your document. Okay, any other questions? Okay, so let's go back to what we were working on last class. So you want to open up your script for our kind of baseball data that we were looking at, and we're going to go over a few more things. I guess I closed out of my slides. Okay, let me make my font a little bigger. So last time what we kind of left off on was doing this kind of polyval right here. So we're going to change a few things. So if you remember from last time, our polyfit that we had, it looked pretty weird. And at the time, I thought it was a rendering issue because of Linux, but it actually wasn't. So if you did polyval, or you did your polyfit like I showed you in class, you would also have a kind of weird looking plot. So we're going to do a little fix for that right now. Okay, so I'm just going back to our code. So let's actually, I'm going to uncomment this, and I'm going to show you what we had last time. All right, so last time, this is what our polyfit kind of looked like. It looks pretty weird, right? So what it's doing here, so white looks weird. You know, it looks a little better once we zoom in, but basically, if I look at val, so this line right here, line 40, what I was doing when I used the function polyval for my x data, I was using fit, and then, or that's our polynomial, sorry, but our x data, I was using the launch angle data that we had. So our launch angle data, we only have a few kind of data points here, and they're spread out. So it's not this even distribution across our x domain. So because of that, it's going to make our polyfit, it's going to make that look kind of weird, right? Because we don't have evenly spaced data points throughout that x domain. So really what we should do instead of specifying the launch angle for the x data, we should specify just our x domain. So I'm going to comment this out now, and we're going to change our line of code to val equals polyval. So the polynomial that we're evaluating is this line of code right here, line 39. That was when we used our polyfit command. And then for our x data, we're going to use our x domain. So for this graph, that was from 0 to 26. Now what I'm doing, I have 0 to 28 because I want to have this curve fit here. I want to have it starting at 0 and kind of going through the graph. So it's taking up the entire x domain of our graph, and it's not kind of stopping right here. Okay, so we change this line of code again just to specify our x data here to be our x domain. And then we're also going to do the same down here when we actually plot the data for our curve fit. So I'm going to comment out line 46. And then I'm going to change it. Again, this is for our curve fit that we're plotting here. Our x data, we're going to have just our x domain. So that'll be 0 to 28 with a step size of 1. And then we're going to plot for our y data all of the data points that we have when we evaluated our polynomial. So that's using line 41 right here. So now if we run that code, now this is what our curve fit looks like. So now it looks nice and good. Okay, so that was just kind of a little fix that we should have. Okay, so string compare. So this is going to be something that's, again, relevant to the project. So before we talked about a function called isMember. So isMember that allowed us to match our string array of Angel player names to a column containing those player names. So let's look back up here. Okay, here they are. So we had, we made a little string array here that was, that contained all of the player names for Angel players. And then in our next line of code, we found the indices for those player names in our table. All right, so to do that, we use two functions kind of in parallel, right? We use the function find. That function is going to basically give us an output or a result of an index. And then we use the function isMember. So isMember, that's going to allow us, in this case, it's going to look at our table that we had, which was called headers. And we basically told MATLAB to look at our table headers and then the column name, or the column that was called player underscore name. So it would compare that column to angels underscore n, which was our string array right here, which contained all of the names for the angel players. So let's actually open up our table and kind of refresh your memory a bit better. So here's our table, and we had a column right here that's called player underscore name. So isMember, again, that's going to look at this column here that we have, and it's going to tell us either yes or no. Does anything in this column, does anything here match our string array for angel players right here on the left? If it does, it's going to return either a 1 or a 0. So a 1 is going to mean yes, and a 0 is going to mean no. That's good, but that would basically have a full column vector that's the same length as player underscore name here of either 1 or 0. We want to know the actual index for our player name, so that's why we use the function called find. So once we use that, that's actually just going to return the specific index for each angel player name. So this was called angels underscore end. So if we clicked on that, then it shows us, or it gives us this kind of vector here. So Mike Trout, he was on index or row number 17. Then Anthony Rendon was row 23. And then David Fletcher, row 33, and then etc. Okay, so instead of using isMember like we've been using, we can use a function called string compare. That's strcmp. That's the function actually inside of MATLAB. So if we're doing this, we can only specify one string. So I can't use a string array like we did use for our angel players here. I can only specify one string, so I can only specify Mike Trout or Rendon, something like that. So you can use either or, and you might be wondering why would you ever use string compare then if it's a little more restrictive for what you can put as an argument. Basically, it's faster than the function that's called isMember. So for our kind of data sizes that we're going to be using for our spreadsheets, even though they're big spreadsheets, they're not really that computationally kind of taxing. So the difference in speed is going to be negligible. So you can use isMember if you want, or if you're just kind of looking for one specific string, like maybe you're trying to look at some county, I don't know, like Orange, right? You can use string compare instead of isMember. Okay, so all of this here, you can reference this, if this didn't make too much sense right now. And but yeah, I talked about everything in this slide now. Okay, let's actually we can go down here. So I'm gonna go in our command window here, and I'll actually type out what we have here just to kind of show you. So if I'm looking for the player Freddie Freeman, how sad now he's not going to the World Series. So close. But if we're looking for Freddie Freeman, we can do find, and we're going to do string compare because we're just looking for him. And then we're going to look inside of our table, which is called hitters, and we're going to reference our column that's called player name. And now we're going to give our argument for what we're looking for. So in this case, we're going to put in a string called Freddie Freeman. And then once I press enter, then we get our answer is 3. So that means row 3. So let's open up our table. And if I look at row 3 for player underscore name, there we go. We have Freddie Freeman right there. All right, so that's string compare. Again, I could change this to using isMember, and I get the same answer. So it's doing the same thing, but remember, string compare, we can only have one argument, while if we use isMember, we can have a variable that contains a string array. So if we do angels underscore n, then we can get all of those corresponding rows for those angel players. All right, removing rows. So we talked about this today. You're going to have to remove some rows for your project. Now, we did talk about this before at some point, but let's go over it again to kind of refresh your memory for how you can do this. Okay, so let's go to our table that we made for angel players. So this is our table right here. So we have all of our players here. We have Walsh, Trout, Rendon, Fletcher, Upton. We have all of them, right? And let's say that we want to remove our last two players here because they make us too sad. We want to remove Joe Adele and Luis Rengifo. Alright, so we can do this in two ways. We can either manually find their index. So we know that that's going to be 9 and 10. That's the rows. Or we can actually write some code. So we're going to use our function here that's called isMember. So let's go through that. So remember, for our data sets for the project, they're pretty big, right? And it would take way too long to manually look up the index. All right, so let me comment out our plot here because I don't want that to show up. Okay, so I'm going to make a new little section here. Oops, I was thinking. I actually use MATLAB inside of a text editor, and I have a little hotkey where I do that and it makes a comment, but who cares? Okay, so make a section called removing rows. And so again, we want to remove the last two players for our table for angel players. So again, we can either manually look up the index, which isn't really recommended. But since we manually looked it up, we can do angels 9, 10. That means rows 9 to 10. And then we want to, I should do 9 to 10 like that. And then we want to remove all of the corresponding columns. So we're going to use a colon. And then we're going to say equals, and then we're going to put these kind of brackets here, and we're going to put nothing inside the bracket. So because we have this, that's going to then tell MATLAB that we want to delete that entire row. In this case, we're going to delete rows 9 to 10. All right, so before I run it, let's look at our table here. So we see them right here. Rows 9 and 10, we have Joe Odell and Luis Rengifo. Now if I run our script, it requires an existing variable. Oh, I didn't. I need to do angels underscore t. That's why. Because we're deleting these rows from our table. So in the slides, my table was just called angels, but in our example in class, I made our table called angels underscore t. Now if I run it, then rows 9 and 10 just went away. So let's comment this out, and I'm going to show you guys the other way. So now we're going to use our function called isMember. Okay, so the first thing that we're going to do, we're going to make a variable here, or we're going to make a variable called sadboys, and we're going to make a little string array here. So we're going to have Joe Adele, and then Luis Rengifo. And so that's our string array, and we want to remove them from our table. So we need to find their indices in the table. So what we're going to do is make a new variable called sadboys underscore ind. That's going to mean sadboys indices. And then we're going to use our isMember function and find. So find, again, that's going to give us the actual row. Then isMember, this is going to be the function to compare our string array to our column in our table. So we have isMember. So now we want to actually put the column name for our table. So angels underscore t dot player name. And now we're going to specify our string array, which we called sadboys. All right, so let's first run this now. So we see sadboys. Yep, right there, sadboys indices, and we see 9 and 10, which we just did manually. So now we can remove those rows by doing angels underscore t sadboys indices, and then we want to remove all of the columns. So set that equal to our empty brackets. Run that now, go back to our table, and they're gone. They won't hurt us anymore. All right, so there we go. So you're going to use this kind of formatting right here for your project. All right, so for a project, we would instead of Joel and Luis Rengifo, we would put out of country and unassigned. Of course, you would use different variable names as well. Okay, so for the rest of this example here, I'm actually not going to go over it, at least right now. If we have time, I will. But everything else in here is not, we're actually not going to do something like this for the project, just because I decided against it in the end, where we have these kind of automated text labels. But this is still good stuff to know. So if we have time, I will go over it at the end, but we're going to go over a more relevant example for the project. All right, so on Canvas, for this week, I uploaded another file that's called COVID-19 search interest. So if you didn't already download that, then download that right now. Or you can just watch me if you want. I don't really care. But we're going to go over basically a rolling average that I was talking about earlier from that graph that I showed you. So we have this graph here, and we see that this is a rolling average or a moving mean, whatever you might want to call it, for 7 days. So I'm going to kind of show you why we would maybe want to do something like that. All right, I need to find where yeah, here it is. All right, so this is the exercise that we're going to do, but yeah, I didn't make slides for this because I did this was part of what I was doing really late last night. I guess I'll just leave it here. Yeah, I didn't want you to do that. Okay, I'm going to quickly get this up on my other computer. So for now, if you didn't download that data, again, go to Canvas and then download that. And then we're going to keep going. Sorry, I didn't see there was a comment. Your array is missing players. What's the full list of players supposed to be in the initial Angels array? Okay, I'll go back to that really quick. Okay, so here's the full list that we had. We had Mike Trout, Anthony Rendon, David Fletcher, Shohei Ohtani, Justin Upton, Joe Adell, Taylor Ward, Jared Walsh, Albert Pujols, and Luis Rengifo. All right, I'm going to close out of this now because I'm going to get my script on my other computer. If you didn't get this done, you can look at it after class, but I want to go over this other exercise. All right, so download that COVID-19 search interest data if you didn't download it already. I'm going to upload this to my drive. All right, I can go back to this now. All right, I'm going to go back here, and then I'm going to get it up on my other computer. All right, sorry, I should have done that the other day. Okay, there we go. Let's see if I can get the chat open too. All right, there we go. Not the best setup, but it's gonna do. If you hear my fans in the background, that's my laptop. It's so loud. It's insane. All right, so let's make a new script here. So we're gonna basically be going over a rolling average. Actually, I'll first show you what we're gonna be doing. So this is the script that we have for COVID-19 search interest. Again, that file that's on Canvas if you don't have it already. So we're gonna make this plot right here. All right, so here we go. We have a Google search interest in COVID, right? So this is for the past 90 days. So if you go to Google and you do a Google search trend search, then you can see the search interest over time. So I did it for the last 90 days because that's the only way that we could do it day by day. I don't know why, but if you increase it to a larger range of time, then Google, they actually use a rolling average by default. All right, so you see here for our Google search interest in COVID, in blue here, I have it going by day. So this is we have data point for each day, and then in red we have it by a 7-day average. So that's it's showing the Google search interest in COVID per day, but it's calculating that by a 7-day average. So in blue here again, that's by day. So what we see is a lot of variability. We see a lot of peaks and valleys, right? But when we use our 7-day average, then those peaks and valleys, they get smoothed out since we're taking an average. So once we do that, it can kind of make our plot basically look a bit more smooth. And this is what you're going to see in a lot of plots, especially for COVID right now. You're going to see that pretty often. So my formatting kind of got all wonky because I'm looking at this in full screen, but right here, it's kind of, it's amusing that there's a spike, not amusing what happened, okay? But on October 2nd, there was a huge spike in the Google search for COVID. And that was when Trump went to the Walter Reed Hospital, got airlifted out. Okay, so we're going to be making this kind of plot. Again, you're going to be using a rolling average for your project. All right, and then we're also going to basically be talking about daytime as well. So we don't have too much time, so hopefully we can cover all of this. But let's make a new script here. Make some comments for ourselves. So on a rolling average exercise. So as usual, make sure that whatever folder you're in for your script, within that same folder you have the data that you want to import. So in our case, that's COVID_search.csv. All right, so let's first clear the memory. Clear memory. So we're going to do clear. You could do either clear or clear all is even better. That's going to make sure that all of your variables are wiped from the memory. And then CLC to clear our text. And we're going to import our data. All right, so what we have here, let's make our variable name called COVID. And then we're going to read table. And now we have to specify our data sheet that we're going to import. That's called COVID_search.csv. I'm going to run our code and then I'll save this. Okay, so I ran the code, right? And we see that we have a warning here called column headers from the file were modified to make them valid MATLAB identifiers before creating variable names for the table. So if I look at our table here, this is what we have. So we see that we have a column called day and a column called COVID underscore United States. So we can get rid of this warning here by using another argument called preserve variable name. So let's do that. Type in preserve variable names. And again, the capitalization matters. And then for the last part, we're going to put comma and true. Now if we're in the code and I click on our table again, it looks a little bit different. So it's preserving the variable names that our spreadsheet had for these kind of column names here. So we have day, and the formatting changed a bit here where it shows COVID, and then a colon, United States. Okay, so that's what we're going to do if you see that error. Some of our data sheets for the project, they might show you that warning. So this is how you can fix it by using preserve variable names and then true. So if I look at this table, this is kind of a weird variable name here. So we're going to change that to just, I think I put interest. Yeah. So we'll do a little comment, rename variables. So if you have a weird variable name and you want to change the variable, you can either actually just, go in the spreadsheet yourself and change it in there, or you can change the variable name inside of MATLAB. So for this, we're going to do COVID, that's our table, dot properties, dot variable names, and then in curly braces, I'm going to specify the variable name that I want to change. So that was COVID, colon, United States. Was it in parentheses? Yeah. Okay, and then we're going to do equals, and then we're going to put our new variable name that we want to use. So we're going to call that interest. Now if I run the code and I click on our table, now we see that variable name that's called interest. All right, so I know I'm going kind of fast, but I want to make sure we can cover everything today. And if you want to rewatch the video, of course, I'm going to upload it. Okay, so look at our table again, and we see this column here for day. We have each day, right? So we have 2020, and then September 19th. We can not September, but July. So we can change that to change. We can change the format here for how this is going to look. So let's do that. Basically, we're going to take out the year and just have the month and the date, or the month and the day. So I'm going to call this change date time format. Also, if we want to see what kind of data type that we're looking at, we can do class. This is going to be the function that we're using. So class, and then we'll do COVID.day, and then our answer is date time. And I can do class COVID.interest, and that should be, yep, a double. So that's just basically it's containing numeric data. All right, so we're going to change our datetime format. So I'm going to do COVID.day equals, and we're going to use the function called datetime. And then we'll change this out when we need to specify our data. So COVID.day. Then I'm going to do comma format. That's going to be an argument. And then we're actually going to specify the format that we want. So we're going to do month dash day. Okay, so this is then going to tell MATLAB that we want 2 digits for our month, and then we want to have a dash, and then we want two digits for our day. Let's close that out. Now if I run it and I go to our table, now we have it by the month and then dash day. All right, so now we want to do our rolling average. So rolling average. Okay, so I'm just seeing what I called this. So COVID dot. I did it like that. Okay, that's fine. So we're gonna create a variable name here called COVID dot interest underscore average. Yes, that's our variable name that we have. And then we're going to use our function. So we're going to use a function here to create our rolling average. This will be called MOV mean. Basically, that just stands for moving mean. If we click on more help, we can read some documentation for this. So basically, our syntax is going to be move mean. The first argument is going to be the data that we want to look at, and k is going to be a number that we want to have for our kind of range for this rolling average. So we're going to do moving mean, and then we're going to specify our data that we want to look at. So that'll be COVID.interest. And then I'm going to put comma 7. So comma 7, that'll make it so we have a 7-day rolling average, just like we're going to do for the project. Okay. So why did I do this part? Yeah, okay, that's for later. Okay, so now let's plot this right now. So I'm going to make another little comment here. So you see here, it's not creating a variable here. That's because we used this dot notation here. So it's not actually saving this variable in a workspace, but it's still like it's still in our memory, so we can plot it. Okay, so let's do plot COVID.day. So that's going to be our date time column, comma COVID.interest. And then I'm going to specify the line width to be 2. And then I'm going to do hold on. So now I'm going to plot our rolling average that we had. So plot COVID.day. That's our X data. And then our Y data, COVID.interest. Get out of here. COVID.interest underscore average. And then we'll specify this line width to be 2. And then hold off. If I run it, there we go. We have our plot. So now we just need to tidy up our X range. Got to add a legend. And you could add the text label if you want. We're not going to go over that part though. We went over that kind of last class. So I'm going to change. Let's actually get the plot back up. Okay, I should have shown that error because I didn't finish typing stuff. So we'll do X ticks. And now what I'm going to do is min COVID.day. Okay, so this is going to get the minimum value for our column for COVID.day. So that's going to basically give us an output of 719. And then for my step size, I'm going to do a step size of 7. So that's going to be a step size of 7 days. And then we're going to go to max COVID.day. And then what I'm going to do is +2. I'll show you why. Let's close that out. Let's run it. There we go. If I didn't have +2, you'll see this better later on. You see that last date went away. Let's put +2 again. Okay. So you'll get a better idea why once I change a little more of the formatting here. So we'll do xlim. We want this to be the minimum value that we had for our date time column. So minimum of COVID.day. And then the maximum x value that we're going to have is max of COVID.day. That box isn't on. Okay, there we go. We run this now. Now our x-axis or our graph is kind of centered in a better way here. And then we'll do x-tick angle. It's 45. Kind of make this look a bit better. There we go. Yeah. Okay, so maybe I changed some stuff. Oh, I need to change this right here, +2. Okay, there we go. So I put in +2 there just so we can see this kind of last date here. So we're not kind of missing information. I can make this a little bit better really because, we have a little space from here till the end, but I don't have enough time to fix that right now. So we won't worry about that. So say this is our plot and we could add a legend. And just making sure I covered everything that I want to go over. Yeah. There is actually one more thing I want to quickly go over. I know we only have 2 minutes, but we're not going to actually make a text label here, but this is just more kind of information on how we can find an index. So I'm going to make a comment here. If we were going to make a text label, that's going to be called find index for October 2nd. So I'm going to do October 2nd index. That's our variable name. And this time I'm going to do find. So we're going to use our function called find COVID.day. That's going to look at our column of all of our days. And then we're going to use two equal signs here. So that's going to be equal to date time. Get out of here. October 2nd. And then we need to specify the format. We have month, day. There we go. So here we go. Right here, we're saying look at our row that was called COVID.day or our column. Look at the column called COVID.day, and if it's equal, okay, we have two equal signs here because we're not assigning a variable or some value here. This is a logical expression, so we're saying find when COVID.day is equal to this date time, which is October 2nd, and then we have to specify the format that we're using for date time. If I run this, yep, and there we go, October 2nd index is 76. So if I look at our table, that should match up. So row 76, that's October 2nd. All right, so I just wanted to go over that so you can kind of understand this syntax right here where we have those two equal signs. That means find when something is equal to something. Okay, if we had one equal sign, that's to assign some value, kind of like we always do with making some variable or some array that's containing data. All right, so I know I went really fast here at the end, so if you want to rewatch this, you can. Again, everything is uploaded onto YouTube, so you can do that. So yeah, we're out of time now. If you have any questions on the project, then stick around or put a question in Discord, but if not, I'll see you guys on Wednesday.
Professor, I have a quick question. I did the code for the rolling thing, and it says